In this module, I am going to discuss about the various applications of colloids. Colloid are mixtures in which one or more substances are dispersed as relatively large solid particles or liquid droplets throughout a solid, liquid or gaseous medium. The particles of a colloid remain dispersed and do not settle due to gravity, and they are often electrically charged. Colloids are widespread in nature and involved in many technological applications. Colloidal medicines are more effective due to large surface area to volume ratio of colloidal particles, and they can easily absorbed by body. Therefore, a large number of pharmaceutical preparations are emulsions. Halibut liver oil, cod liver oil, skin ointments are emulsions. Penicillin and streptomycin are produced in colloidal form for suitable injection. Colloidal gold and colloidal calcium are used as tonics. Milk of magnesia is used for stomach troubles. Silver salts protected by gelatin known as agriol is used as eye lotion. Colloids have great application in food industries and foodstuffs. Many of the food material are in colloidal nature. Emulsions like mayonnaise and salad dressings rely on colloids to prevent separation of oil and water components. In ice cream, colloids help to maintain a creamy texture by controlling ice crystal formation. Colloids are also used to improve the mouthfeel, texture, and appearance in products like sauces, soups, and beverages. Milk and milk products like cheese, cream, butter are colloids. In more accurate way, milk is an emulsion. In milk, butter and fat are dispersed in water. Bread is colloidal system in which air is dispersed in baked dough. Additionally, colloids can enhance the shelf life and sensory attributes of food products, making them a key ingredients in the food industry. Impure water usually contains dispersed colloidal particles. These colloidal particles cannot be removed by filtration. Certain electrolytes such as potassium, aluminum sulfate are added to impure water. Coagulation takes place. When potassium is added to impure water, the negatively charged colloidal particles of impurities get coagulated by the action of aluminum ion and form large particles called flocks. The flocks then settle down due to gravity, or it can be easily filtered out. This helps in the efficient removal of impurities from the impure water. Sewage water contains particles of dirt, mud, etc., which are colloidal in nature and carry some electrical charge, and therefore they do not settle down easily. These particles may be removed by using the phenomenon of electrophoresis. The sewage water is passed through a tunnel fitted with metallic electrodes and maintained at a high potential difference. The colloidal particles present in the sewage water migrate to the oppositely charged electrodes and get coagulated. The deposited matter is used as a manure, and water left behind is used for irrigation. Smoke is the major source for air pollution. Hence, the dispersed colloidal particles must be removed from the air. In this case, the process of electrophoresis is used and it is done by cotral precipitator. Smoke is passed through a chamber. This chamber contains a number of metal plates attached to a metal wire. This metal plate is connected to high potential source. The electrically charged colloidal particles of carbon present in air get discharged when come in contact with the oppositely charged plates and fall down to the bottom. The clean, hot air then leaves the precipitator from an exit near the top. In clouds, the water vapor are present in mixture with the dust particles. Cloud is a colloidal system. Water molecules present in cloud have electric charge. So, if the charged water molecule is neutralized, they will start raining. When the oppositely charged colloidal dust particles spread over the clouds, the colloidal water particles of cloud gets neutralized and coagulation causes the artificial rain. Rubber is synthesized from the latex obtained from the rubber trees. This latex is an emulsion in which the negatively charged particles of rubber are dispersed in water. For obtaining rubber, this latex is boiled, because of which the rubber particles get coagulated. This coagulated mass is then vulcanized to solidify as natural rubber. Tanning is the process of treating the skins of animals to obtain the leather. The tanning of leather is based on the mutual coagulation of oppositely charged colloids. The animal skin is positively charged colloidal system containing albumin and gelatin in the colloidal state. When treated with negatively charged colloidal system of tannin, which is present in barks of trees, wood, leaves, a mutual coagulation of two oppositely charged salts takes place. As a result, the surface of leather becomes harder. Dyeing is essentially an adsorption of dye by the colloidal particles of marten used. The cloth like cotton, wool, silk are colloidal in nature, and martens used are also colloidal in nature. The martens like aluminium hydroxide, stannous chloride, tannin are readily adsorbed by fibers. This is another typical case of colloidal state of matter. The soap solution is a colloidal system and it removes the oil and dirt by forming water-soluble emulsions. Soap molecules form micelles in water. It can clean the dirt as the dirt is trapped within the micelle. The micelle form to make a colloidal solution with the water. When the cloth is washed with soap and water, the hydrophilic end gets attracted by water and the dirt particle that has been trapped inside the micelle gets washed away with the water. Smoke screens are used to hide something by a layer of smoke. Generally, it is used to hide the movement of troops. The smoke screens are also colloidal system in which the particles of titanium oxide are dispersed in air. The extensive deposits of sand and clay formed at the mouth of any river in sea at the site where the river falls into the sea are called delta. The formation of delta is a very interesting natural phenomena in which the negatively charged colloidal particles of river are neutralized and thus coagulated by the positively ions of the salt which is present in sea. As it is very expected, the river water contains colloidal particles of sand and clay which are negatively charged. On the other hand, the salty sea water contains a number of positive ions. When the water of river comes in contact with water of sea, the negative charge present on colloidal clay particles present in river water gets neutralized by the positively charged ions present in sea, because of which they get coagulated and deposit at the site. Natural honey is also colloidal in nature. The distinction between the two is made by Ly's test. It consists of treating few drops of honey with ammoniacal silver nitrate solution. In case of pure honey, metallic silver produced assumes reddish yellow color is due to the traces of albumin and ethereal oils, which act as protective colloids. The dark yellow or greenish precipitate is formed with artificial honey. The blue color of the sky is a result of the scattering of sunlight by atmospheric particles. These include colloidal particles such as water droplets and air molecules. These colloidal particles scatter short wavelength blue light more than longer wavelength red light, giving the sky its blue color. Rain, fog, and mist are examples of colloidal suspensions of water droplets in the air. These colloidal suspensions play an important role in the water cycle as they help to transport water vapor from the atmosphere to the ground. The blue color of the sea is also due to the scattering of light by colloidal particles in the water, including dissolved organic matter, plankton, and other microscopic particles. The scattering of blue light by these colloidal particles giving the sea its blue color, while the absorption of other colors by the water can give rise to green, red, or other hues in different parts of the ocean. Colloids play an important role in nanotechnology, influencing various applications across different fields. Colloidal methods are used to stabilize nanoparticles in solution, preventing the aggregation and ensuring uniform size and distribution. Processes like salt gel synthesis utilize colloidal suspensions to create nanoparticles with specific properties. Colloids can serve as carriers for drugs, enhancing solubility, stability, and bioavailability. The functionalized colloids can target specific tissues or cells and reduces the side effects. Colloidal silver or gold nanoparticles can enhance signals in biosensor for the detection of biomolecules. Colloidal catalyst often composed of metal nanoparticles and it enhances the reaction rate in chemical processes. Colloidal system can facilitate the green chemistry by enabling catalytic reactions under milder conditions. Colloidal nanoparticles known as quantum dots are used in display, solar cells and LED technology. Colloidal dispersions of metallic or conductive nanoparticles are used to create transparent conductive films for touch screens and solar cells. Colloidal nanoparticles can be applied to surfaces to create hydrophobic and oleophobic properties, resulting in self-cleaning materials. The incorporation of colloidal nanofillers in polymers can improve the strength, flexibility, and thermal stability. Colloidal nanoparticles are employed in techniques such as magnetic resonance imaging for separating biomolecules. Colloids play an important role in various aspects of road construction and maintenance. Colloidal silica can be used to improve the strength and durability of soil layers. Colloidal polymer emulsions can stabilize the soil, preventing erosion and dust formation, which is particularly used in unpaved road construction. Colloidal asphalt emulsions can improve the adhesion of asphalt to aggregates and enhance the performance of road surfaces. The incorporation of colloidal nanoparticles can enhance the thermal stability, flexibility, and resistance to cracking in asphalt mixtures. Colloidal dispersions can be used as superplasticizer in concrete to improve the workability and reduce the water content. Colloidal suspensions can enhance the property of sealants used on pavement, improving the water resistance, UV stability, and protection against chemical spills. Colloidal based material can be used in crack fillers and repair mortars for maintaining the existence of pavement infrastructure. Colloidal solutions can be applied to unpaved roads to reduce the dust emissions, improving the air quality and visibility for vehicles. Colloids can facilitate the use of recycled materials such as reclaimed asphalt pavement by enhancing the binding properties and performance of these materials in new mix. In stormwater management systems associated with roads, colloids can help to improve the filtration and removal of pollutants from runoff, contributing to sustainable road design. The application of colloidal material can improve the performance of geosynthetics used in road building such as geogrids and geomembranes by enhancing their durability and interface interaction with soil. The colloidal encapsulations can help in regulating temperature in pavement materials, reducing heat-related damage and improving the user comfort. Colloids play a significant role in various metallurgical processes, enhancing the efficiency and effectiveness of metal extraction, refining, and alloy production. In mineral separation, colloid stabilized particles are used in froth flotation, a common method for separating valuable minerals from gangue. Surfactants and collectors are often colloidal in nature, improving the hydrophobic properties of mineral particles and allowing them to attach to air bubbles and give rise to surface. Colloidal solutions can enhance the leaching of metals from ore. Certain bacterial colloids produce leachate solutions rich in organic acids that aid in the solubilization of metals from ore. Colloidal systems can be employed to maintain a stable suspension of metal ions in electrolytic bath, improving the uniformity and quality of deposited metal layers, such as in electroplating. Colloidal techniques are used for the removal of heavy metals and other pollutants from wastewater generated by metallurgical processes. Flocculant, which are often colloidal, aid in aggregating and removing the suspended contaminants. Colloidal processes is employed in the production of metal and ceramic powders, enhancing the sintering processes through improved dispersion and particle size control. Colloidal binders are used to enhance the mechanical integrity of ceramic and metallic structures during forming and sintering operations. Colloidal particles can help stabilize the suspensions of metal in various processes to prevent agglomeration, ensuring even distribution during processes like casting or building. Colloids are used in creating advanced coatings and nanostructured material that improve the mechanical and chemical properties of metal, such as corrosion resistance and wear resistance. The application of colloids in metallurgy enhances both the efficiency of metal extraction processes and the quality of the final products.